So I would like to do the first work, where a set is given work number 1. A set C is given where the elements are -9, -6, -3, +3, +6, +9. Now I have to express this set by using a set building method. Since this is already given in the tabular method, so I have to convert this using set building method. Okay. To convert a set from a tabular method to a set building method, what I have to do, I have to find out the common properties. Here you can see all the items are ranging between -9 to +9. This is one properties, and the other property is that you can find that all the numbers are multiple of 3. Okay, so these are the two common properties, and I have to use these two common properties, and then I have to prepare the sets. What is the first properties? Here we can see that all the elements are multiple of 3. These can be treated as the first properties, and all the elements are ranging between -9 to +9. Okay. So if I would like to prepare a set using the set building method, what I have to do, let's say C is the set of element X such that X are multiple of 3. This is one properties. Okay, and the variable X are ranging between -9 to +9. Actually, this is the answer using the set building method. Okay, I hope you can understand all these problems. What I am I am trying to understand you, make you understand. And if you have any problem regarding this, you can comment on the comment box. Okay. Now I would like to move to the second problem, work number 2, where it is given that B is a set of element Y such that Y is integer and Y cube is less than or equal to 18. Now I have to convert this set and express this set using the set building method. Sorry, it is wrongly written. It should be tabular method. You know, this is already given in set building method, so you have to convert this using the tabular method. So what we have to do to express a set from a set building method to tabular method, we have to break down all the common properties into details. So the set B, it is given that set B is a set of element Y such that Y is integer and Y cube is less than equals to 18. This is the properties number 1 and this is properties number 2. So first of all, if I would like to break down these properties into details, I will find, since Y is integer, it is not given that y is positive or negative integer. It is only said that y is integer. So y can be y equals to maybe -3, -2, -1, 1, 2, 3, 4, or something like this. All integers, all positive and negative integers. Okay, this is the details of first properties. And now I would like to find out I would like to satisfy these criteria by using these values. So if y equals to -3, then y cube equals to -3 cube means -27. Okay, so therefore y cube -27 is less than 18. I mean, these values is satisfying this criteria. Okay, so y cube is less than 18, y cube is less than or equals to 18, and this is true. Therefore y equals to -3 is an element of this set. If y equals to -2, then y cube equals to -2 cube equals to -8. -8 is less than 18. So y cube is less than or 18. Hence y equals to -2 is element of this set. If y equals to -1, then y cube equals to -1. Therefore y cube -1 is also less than 18. Hence y -1, sorry, you can say -1, -2 or -3 is an element of this set. Just write, you can write like this. If y equals to 1, then y cube equals to 1 cube means 1. Therefore y cube 1 is also less than 18. Hence +1 is also an element of this set. If y equals to 2, then y cube equals to 2 cube means 8. 8 is also less than 18. Therefore y cube is less than 18. Hence 2 is also an element of this set. If y equals to 3, then y cube equals to 3 cube. 3 cube means 27. You know, 27 is not less than 18. Therefore y cube is greater than 18. Okay, so 3 is not an element of the set, is not an element of the set. And if we move further, say for example y equals to 3, if we take y equals to 4, then it will be also 64, which is also greater than 18. So we should not go further, but you can it is very clear from that, from these illustrations, that you can find if we take all the negative values, they will be less than 18. So all the negative values are acceptable, but in case of positive values, only 1, 2 and 1, 2 are acceptable, not 3. So what will be the set? If we prepare the list, now we would like to prepare the list. Say for example the set is B, and the listed elements will be all the negative elements will be acceptable, but we are using just -3, -2 and -1, and -3, -2, -1, and in case of positive elements only 1 and 2 are acceptable. So this is the answer. Now I have to define a finite set. Finite set, the finite set can be defined as the set which has a limited number of elements, which has a countable number of elements. You can count the elements of finite set very easily. Okay, if I say A is a set of 1, 3, 5, 7, 9, and the items are only 1, 3, 5, 7, 9, only 5 elements. This is a finite set. And also so for example, if I say B is a set of element x such that x is all even numbers, all, say for example, all prime numbers, and x is ranging between 1 to 10. This is also a finite set. It's a x is a set of element x such that x are all positive numbers, all prime numbers, and x is ranging between 1 to 10. So you can find a limited number of items and you can very easily count them. Here you will find 1 to 10. The list of prime numbers would be 2, 3, 5, 7. Yeah, that's all. These 4 items, all prime numbers. All prime numbers means, say for example, if I would like to prepare a list from this set, then all prime numbers would be 2, 3, 5, 7, 11, 13, blah blah. This is from the first properties, and from the second properties, x will be ranging between 1 to 10. So we will take only 2, 3, 5 and 7. These 4 elements are the member of this set. So elements are very easily countable, only 4 elements. So this is a finite set. Okay, now would like to define infinite set. Infinite set is exactly opposite of this. You cannot count all the items of infinite set. Infinite sets will contain unlimited number of elements, and the items cannot be exhausted, okay, by counting. I would like to give some examples. Okay, let's say A is a set of all prime, A is a set of x such that x is all even numbers. All even numbers, there are unlimited number of even numbers, so you cannot exhaust them by counting. Okay, for another example I can give you, that is say for example, B is a set of element y such that y is all real numbers. There are a huge number of real numbers, unlimited number of real numbers, so you cannot exhaust them just by counting. So this is also an infinite set. Okay, now a problem is given that and I will advise you to go for the book or go through the book just for using to pick up the definitions. Okay, but what I have said, I have just given you the ideas. Okay, to get the exact definitions, you should go through the book. Prove that the set of all natural numbers is an infinite set. This is example number 4. Set of all natural number is an infinite set. So say A is a set of all natural numbers. All natural numbers means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah blah blah. You cannot just exhaust them. Okay, the numbers are continuously moving to infinite, unlimited number of items are including in this set. And say for example, B is a set of all even numbers. So all even numbers would be 2, 4, 6, 8, 10, blah blah. And C is a set of all odd numbers, 1, 3, 5, 7, 9, blah blah. If I would like to prepare another set D, which will contain all the numbers that are multiple of 3, so the number would be 3, 6, 9, 12, blah blah. Here all these numbers are, you see, all these numbers are natural numbers. These are all even natural numbers, all odd natural numbers, and all natural numbers that are multiple of 3. Okay, now we can see that all the sets B, C and D are containing the numbers that are infinite. There is no limit over here. So since all these 3 sets are having unlimited numbers, so all the natural numbers, all the natural numbers are, all these set B, C and D are the subset of all natural numbers. Since all these set B, C and D are having unlimited items or are infinite sets, so the set A will also be an infinite set. Okay, now I have to determine the finite and infinite sets from some examples given from the books. I would like to, there is a set given which had an element, let's say number 1 problem, a set, it has 3, 5 and 7. This set has only 3 elements, so this is very easily to count. This is very easy to count, and the number of items are very limited, only 3 items. So this is a finite set. Okay. Secondly, another set is given 1, 2, 2 square dot 2 to the power 10. And you see there since I can rewrite these items as 2 to the power 0, 2 to the power 1, 2 to the power 2, dot 2 to the power 10. You see the items, the initial items has started with 0 and the final items has ended with 10. So I can see there are only 11 items within this set. So this is an finite set, since only 11 items are within this. Only 11 items are, this set is containing only 11 items, limited number of items, so this is a finite set. The third set is given 3 square 3 cube dot dot. It can be rewritten as 3 to the power 0. Sorry, it is 3 to the power 1. It can be rewritten as 3 to the power 1, 3 to the power 2, 3 to the power 3. 3 1 3 square 3 3 3 cube. So we can see that the initial items has started with 1, 3 to the power 1, but there is no final items. Since it has no final items, I mean it is this set contains unlimited number of items, so this is an infinite set. Number 4, given a set given an element of x such that x integer, x is integer and x less than 4. If initially I would like to convert this, so I would like to convert this into convert this set into a roster method or a tabular method, a set of roster or tabular method. I mean I would like to list the items. So the if this is an MCQ questions, this is if I will give you the short answer, that is all the items are limited within x. I mean x is less than 4. So the items can be, it maybe it has the limit in the positive side, but in the negative side, since integer can be negative, in the negative side there is no limit. So this is an infinite set. This is the short answer, but I would like to convert this using roster method so that it can be clear. So the first property is x integer. X integer means x can be maybe -3, -2, -1, 1, 2, 3, 4, 5. Okay. Since x is integer, so it can be unlimited number of positive integers and it can be unlimited number of negative integers. This is from the first properties. But from the second properties, x is, but from the second properties it is given that x can be x is less than 4. But x can be only 1, 2 and 3 since it is less than 4. So the items will be, finally the items will be all the negative items, and from the positive side only 1, 2 and 3. That means positive side we have a limited number of items, but in the negative side there is no limit. Since it has no limit, ultimately it will become an infinite set. Okay. Number 5, a set is given where p by q, p and q are mutually co-primes and q is greater than 1. From the definition of rational numbers, what we have find, all rational numbers can be expressed as p by q, where or such that p and q are co-primes. P and q are co-primes and q is greater than 1 or q cannot be 0. So this is exact definition of rational numbers. I can rewrite these as all rational numbers. All rational numbers, so there is no limit ultimately, and this can be an infinite set. And the final one is given as y, a set y element such that y is y belongs to n, means natural numbers, and y square less than 100, y square is less than 100 and less than 100 less than y cube. If I would like to give the short answers, then it will be a finite set, since there is a limit given, so it will be a finite set. But I would like to convert this set into a set using the roster or tabular method, then it will be very clear to you. Since y belongs to n, I mean all natural numbers, therefore y equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 or something like this. Now I would like to test these conditions or properties. If y equals to 1, then y square will be 1 square means 1, y square equals to 1, which is less than 100. Therefore y square is less than 100. Okay, now I would like to y cube. I will test y cube. Y cube means 1 cube means 1. Therefore y cube is greater than 100. No, this is 1. 1 cannot be greater than 100. So y cube is less than 100. Y cube is less than 100. It was supposed to be greater than 100, but it is less than 100. So from this both criteria, this criteria is satisfied, but this criteria is not satisfied. So 1 is not the element. 1 is not an element of this set. Okay. Similarly, if y equals to 2, then y square equals to 2 square equals to 4. Therefore y square is less than 100, because 4 is less than 100. So y cube equals to 2 cube means 8. So y cube 8 is not greater than 100. Therefore y cube is less than 100. So both this condition or this criteria is satisfied, but this is not satisfied. Okay, so 2 is not an element of this set. Y equals to 3, then y square equals to 3 square equals to 9. Since 9 is less than 100, so y square is less than 100. Y cube equals to 3 cube equals to 27. 27 is not less than 100. 27 is less than 100. Yes, not greater than 100. So y cube is less than 100, not greater than 100. So this condition is satisfied, this condition is not satisfied. So 3 is also not an element of this set. Y equals to 4, then y square equals to 4 square equals to 16, which is less than 100. This condition is satisfied. Y cube equals to 5 cube equals to 4 cube equals to 4 cube means 64, which is also less than 100. So y cube is less than 100. This condition satisfied, this condition is not satisfied. So 4 is also not an element of the set. Now I will go for 5. Y equals to 5. Then y square equals to 5 square means 25, which is less than 100. So this condition is satisfied. And y cube equals to 5 cube equals to 125. And this 125 is also greater than 100. So this condition is also satisfied. Therefore 5 is exactly the element of this set. 5 is the element of this set. Okay, I have to move to the top. So if y equals to 6, then y square equals to 6 square means 36. Therefore y square is less than 100. This condition is satisfied. Y cube equals to 6 cube means 216, which is also greater than 100. So both these conditions are satisfied. Therefore 6 is an element of the set. Okay, if y equals to 7, then y square equals to 7 square means 49. So y square less than 100. Y cube 7 cube means 243. Therefore y cube is also greater than 100. Both these conditions are satisfied.